Today, the universe may or may not be an atom, but it is definitely filled with plagiarism. I came across this video shortly after I did Is the Universe an Atom? Card. It seems remarkably similar on the surface. I dare say there's some obvious copying going on here. But the question is, will they have something convincing? As always, this video is edited for time. If you want to see the full video, it's linked in the description. We're going to get right into it. But first, if you're new here, please take a moment to hit that subscribe button. It helps a small channel like this out tremendously. I greatly appreciate it. Thank you. And now, let's delve into the quantum realm.
Everything consists of atoms. This knowledge is about 100 years old, but
Right off. We're like 1 second in. Obviously, the ancients knew about atoms, at least as a concept. It goes all the way back to the ancient Greeks and possibly even earlier. Knowledge as in confirmed observations is a little bit more than 100 years old, and that's a little trickier because atoms are very, very small, but we have had indirect evidence that there were such a thing as atoms as long as we've had a periodic table, because we had to be able to categorize what these elements were that were forming the molecules we were studying.
today we know much more than that because the supposedly smallest particles of matter are actually something like tiny universes. So is it possible that
Wait. Did he just throw out there, just as if it were a stone cold fact, they're a lot like tiny universes? Okay, so on the plus side, we're diverging from the other video very, very rapidly, and I guess that's to the good. I don't want to review a video that's just a clone of the other video. But on the flip side, that's a straight-up assertion and demonstrably false. I wonder what we're getting ourselves into here.
we ourselves and our universe are in fact just a tiny particle in a much larger world?
Well, I mean, we are a tiny particle in the much larger universe. There's a reason that we refer to the Earth as the pale blue dot, a speck in a sunbeam, as the famous photo puts it.
This video will explore this question and other exciting details about atoms and the blueprint of our universe. All things are made of atoms.
Kind of, but not really. There's quite a lot of things that are not made of atoms. Every form of energy is not made of atoms. Photons are not made of atoms. The component parts of atoms, like protons, neutrons, quarks, not made of atoms. The statement is just not true.
In 1808, British researcher John Dalton first discovered atoms. He and his colleague.
So 1808, first discovered atoms. Okay, discovery. Cool. It's not 100 years ago.
Joseph Louis Proust were concerned with the question of why chemical elements combine to form molecules only in certain integer ratios. The only logical explanation was that the elements consist of smallest units that can no longer be divided. This idea,
Well, that wasn't the only possible explanation. People were drawing on the old ideas of the indivisible substrate of matter, the fundamental building block. That was a popular solution to the problem, but it wasn't the only solution to the problem.
was actually not so new, but was already proclaimed in antiquity by the so-called atomists. This school of scholars active in ancient Greece at about the same time as great thinkers such as Socrates and Plato had the idea as early as the 5th century BC that all of creation is made up
Ooh, creation. I don't like loaded terms like that.
of indivisible particles. They called these particles atomos, which simply means indivisible. How the ancient Greeks attained this knowledge still amazes scientists today.
It's philosophy. Just because it turned out to be right, well, semi-right. We know that atoms are divisible, but the fact that there turned out to be things that we named atoms because of their resemblance to this ancient philosophy, it shouldn't be a mystery.
Because in ancient times, there were no magnification techniques and no computers. By the
Well, that's not entirely true either. We didn't have lenses as we think of them today. There were certainly methods for magnification, the focusing of light, and other various fun things. And if you believe certain archaeological finds, the ancient Greeks probably had mechanical computers too. Details though, right?
way, even today, It's very difficult to make atoms visible. There are some methods by which only the outer region of the atom, or in other words, the electron shell, can ever be visualized.
Here's a famous photograph with a regular camera of a single atom.
The rest of the knowledge is based on calculations and observations and experiments. The pioneer in the field of modern atomic research was Ernest Rutherford. In 1907, the Manchester University professor and his colleague Hans Geiger bombarded a thin metal plate with radioactive alpha particles. Most of the alpha particles passed directly through the metal plate, but a few were slightly deflected in their trajectory.
So, minor note, but the alpha particles, which are basically just naked protons, they're not radioactive per se. They're the product of radioactive decay.
And occasionally, one of the particles was thrown directly back by an object. The deflection as well as the rejection had to be caused by atoms, based on the observations.
There's a lot of details that kind of skirt the truth in this video, but no, what was actually learned from the experiment, that even though the metal sheet was solid matter, there's actually a tremendous amount of empty space in between the particles comprising the solidity of the matter. They observed that something was shooting back these alpha particles. To say it could only be atoms, no, it was strong evidence that atoms, the hypothesized building block of matter, might exist. It was pretty strong evidence, but it was hardly conclusive at that time.
So basically, the atom became visible by being bombarded with a beam of tiny particles. This way of making atomic structures visible is still used today.
Which is fascinating, because by theorizing that there were positive particles and negative particles comprising the atoms, we already, before we had even officially discovered the atom, also discovered that there were subcomponents, that the atom was in fact divisible.
Researchers of the 21st century have gigantic particle accelerators and ultra-fine measurement sensors available for this purpose. And these atoms, as we now know, are made up of electrons, protons, neutrons, and even much smaller particles called quarks. The smallest unit in the subatomic range has not yet been found. Researchers sometimes call this particle the God particle.
I'm not even sure where to begin with this. Obviously, the God particle is considered to be synonymous with the Higgs boson, which was discovered years ago at this point. Remember, this video is 2 weeks younger than the video it's plagiarizing. So it's not exactly outdated information, but it's presenting outdated information. We have discovered the Higgs, and it's
whoever finds it is thought to unlock the blueprint of creation. But before we take a closer look, let's turn to a completely different topic. Is the atom a cosmos in itself?
Wow, I got whiplash from that transition.
In the inside of the atom, protons and neutrons dance and are orbited by electrons, just as planets orbit stars and star systems.
Oh, here we go. Now we're back on track with the other is the universe and atom thing. Now we could see in the two visuals, he says, just as planets orbit stars. Obviously, it's not the same. The first visual, the electrons are orbiting in all three dimensions. In a planetary system, the planets are orbiting generally along the elliptical plane around the star. It's not the same. It's not even close to the same. The passing similarity is something that virtually all high school chemistry students think and then immediately dismiss because there's so many things that don't match.
Researchers even claim to have discovered that the rotation speed and orbits of particles inside the atoms of certain elements exactly resemble the orbits of planets in our solar system.
And that is completely made up. Electrons always move at the speed of light. There is no similarity to a planetary orbit. There is no planet whose orbit comes anywhere near the speed of light, but doesn't have any kind of relation to the speed of light. There's no ratio between them. There's no established relationship. And also, what about moons? More planets than not have moons. Have we detected any electrons with something smaller still orbiting them? But hey, we're back on script now. This is Universe is an Atom, Scientists Are in Panic classic. It's exactly the same stuff that was presented in that one, if in a different way.
The idea of the micro worlds in macro worlds has been taken up by Hollywood already several times.
Yeah, most recently with Quantumania, if you prefer.
In the hit movie Men in Black 1, the cat Orion wears an entire galaxy as a pendant on his collar, and at the
There's some solid science right there. Men in Black with the goop guns and the regenerating alien heads, and yeah.
At the end of the movie, viewers realize that the cosmos of Agents K and J is contained in the marble of an alien.
Galaxy. It's a galaxy.
This idea immediately picks up the theory of the pocket universe, according to which
a pocket universe is not the same. For fuck's sake. So in multiverse theory and some cyclic inflationary models, there's this idea that portions of the universe could cut off from the main part of the universe and experience their own inflationary event and create a smaller universe, a layer down from our universe. It's not at all what this dude's talking about.
Parallel existing worlds are not linearly nested into each other like Russian dolls, but are arranged along previously unknown non-linear structures. Let's come back to the...
So that was just a big bunch of word salad. Parallel dimensions don't necessarily have to run in parallel. Of course, we have no reason to believe parallel dimensions exist, but if they did, they don't have to be parallel. But that's a whole other thing.
World of science, we note again that the structure of the smallest particles and atoms is similar to the structure of the universe. And
no, we don't. That was a picture of an atom. This is a different kind of model of an atom also. If you could show me a galaxy cluster with one big knob of galaxies in the middle and a bunch of tiny galaxies zipping around the outside at the speed of light, then there'd be some similarity. But we don't see that. No, just no.
An atomic nucleus orbited by electrons forms a molecular bond with other atoms, which in turn
The atomic nucleus does not form molecular bonds. The electrons, shared electrons between atoms, form covalent bonds, for fuck's sake.
gives rise to diverse forms of matter. If the nature of the atom would be the same as that of the universe would have to have a boundary. We know so far the shell of the atom, but we do not know whether the universe is infinite or limited. Today, we know that
This is actually a fair question because it's really hard for the human brain at its current stage of evolution to conceptualize. Most of us think of the universe as being a ball, and all of time and space is inside the ball. And because we conceptualize it that way, it has a boundary. Most of our pictures of it, our depictions, our models, our presentations, all of it has a boundary. But we don't know that there's a boundary. If you were to travel through space at the speed of light, or even faster, if you somehow went 10 times the speed of light or 100 times, you would not come across a boundary. There isn't one. If there were a physical spatial edge to the universe, then that would have to mean there is a center point. And if the universe has a center point, it collapses instantly. There is no universe. The Big Bang happens and immediately crunches back up. Therefore, the universe cannot have a boundary in the conventional sense, in the spatial sense. And so, in that way too, it is nothing like an atom.
electrons, neutrons, and protons are not the smallest particles. They are formed by quanta, which are nothing else than pure light, but all
Okay, so quanta, the origin of quantum physics, is, back in the day, we used to think that things like stars emitted an infinite amount of light, but we quickly realized that makes no sense because you can't do that. You would irradiate the universe instantly. It has to be a finite amount of light. It has to be a measurable amount of energy being shot out into space in all directions. So how do we figure out what that is? TLDR, we figured out that there is a smallest amount of energy that can be emitted by an excited atom. One photon. If you excite an element, it will raise an electron to an orbital shell, but that electron wants to go back down to its stable state, so it will emit some of that energy, but it can only do it in discrete units, 1 photon at a time. That is 1 quanta, the smallest amount of energy that can be emitted as an electromagnetic wave in a single go. That's where quantum physics begins from. That's the starting point.
Also, the quantum is not really the smallest particle. Rather, quanta are only half particles. In the experiment, it
That's interesting. Let's see where this goes.
turned out that quanta can choose between the particle form and the existence as undefined wave in space, or that external influences decide whether a quantum takes a solid form or forms an undefined wave.
Okay, he's referring to wave-particle duality there. That doesn't mean it's half a particle. So, it's a long discussion, but TLDR, sometimes we can consider a photon or other quanta to be a wave, and sometimes we can consider it to be a particle, depending on which formulas we're using it for. Now, there is the whole thing with the double slit experiment, and I'm probably going to get into that fairly soon, because there's a huge amount of misunderstanding, even among scientists, when it comes to the double slit experiment and the observer effect and all of that. But for the sake of this video, the fact that sometimes we can consider it a wave and sometimes we can consider it a particle, depending on which math we're working on at the time, does not mean it is half of one and half of the other.
The role of dark matter.
Okay, and
So
we're just
far,
shifting topics again. Cool.
researchers are still looking predominantly at visible phenomena in space, although quanta are already pushing science to the limits of being and non-being. Quanta becomes waves when they are not determined or measured. If you have occupied yourself with
Now he's really starting to lean into the double slit experiment, which, again, it needs to be its own video. It's a huge topic, but TLDR, there's this idea, the observer effect, that when you observe a wave, it starts acting like a particle. That's not strictly true, but this idea is out there. So what he's referring to is, with regards to Heisenberg's uncertainty principle, when you observe a wave, it collapses into a single point. But of course, now you've nailed it down to a single point and its behavior becomes harder to predict because you've interfered with it. And so the uncertainty principle kicks in. You can never know both the precise location and precise velocity of a subatomic particle. And that's not because it's a huge rule of the universe that you can't violate. It's because of the physics of the observation. If you ping an electron with a photon, which is the same size, it's going to deflect it. So a lot of this mysterious wave particle uncertainty woo, it's just a basic misunderstanding of fundamental principles.
quantum physics or watch our videos regularly, you know the thought models that say the moon would disappear if nobody looked anymore.
Fucking what? The moon would disappear if nobody looked at it anymore. That has to come from a gross misunderstanding of the observer effect. If people stopped observing Pluto, Pluto would not exist. But we didn't know Pluto existed until we observed it. Like, how could we discover anything we weren't already looking at if it depended on our observing it to exist? That makes no freaking sense.
In any case, this is the world in the cosmos of the smallest particles. Quanta appear seemingly from the nothing and then take shape or disappear again. This phenomenon is known to scientists as quantum fluctuation or vacuum fluctuation.
So that's not the same thing as quanta. Again, a quanta is just the smallest discrete unit of energy that can be emitted or absorbed. What he's talking about with vacuum fluctuations is virtual particles that spontaneously pop into and out of existence, not the same as quanta.
Science is slowly approaching the nothingness or vacuum from which quanta emerge, both at the subatomic level and in the universe. This nothingness or zero-point field, dark
Oh, now he's on about 0 point. Okay, so 0 point. That's a whole other thing. So again, it is a gross misunderstanding. Theories have been put forth that the total mass and energy of the universe actually comes to a sum of zero. That there's some positive energy and some negative energy, some positive mass and some negative mass, but it's a wash overall across the universe. And we see some evidence for that in the way electromagnetic radiation is structured. The typical depiction of the light wave, a normal sine curve. It's like a +1 and a -1. So it totals zero, but that's not the same as none. That's why photons have mass. Even though it's zero mass, they have a mass and are affected by the bending of time-space due to massive objects. It's a whole thing. It's a popular misunderstanding, it's a common misunderstanding, but it is a misunderstanding.
Until now, science assumed that atoms are held together by the distribution of charges and the relations between neutrons, electrons, and protons. This would be similar to the universe being held together by the movement of stars and galaxies.
No. Galaxies are held together by gravity. That's a monodirectional force.
In certain places, such as black holes, the nothing is so compressed that
a black hole is kind of the opposite of a nothing. It's kind of all the things are crammed into a single point.
It has enormous gravitational forces. Consequently, it must be a kind of matter. And also, this can act as a...
What? Yeah, there's matter in it. It's the core of a collapsed star.
Kind of glue in the atom as well as in the universe. It's probable that the real secret of the construction plan of the universe and the atoms is hidden in the dark matrix.
The construction plan of the universe, assuming there is one, is hidden in the dark matrix. I feel like we're just throwing out words that sound cool at this point. We're not even on science anymore.
Light appears from this darkness like mushrooms from the earth.
No, light does not appear in an unknown way like mushrooms from the earth. Light is produced by matter emitting it, like stars do. Holy crap.
Mushroom, the actual living being, is the meshwork that lives under the earth, and not the mushroom visible above the earth.
Now we're misunderstanding biology. Okay, he's kind of on point by saying that the majority of the organism is the filaments that are within the thing that is infested with the fungus or whatever the case may be. The main nutrient collecting part of the organism. And the reproductive elements, the mushrooms and other spore producing things, are not the same as the whole organism. But just like any part of an organism, they're just as alive as the rest of the organism.
Transferred to the universe or the atom, one could say consequently that the actual form exists in the darkness or in the nothingness.
One could suppose that, but one would need some reasons to support that supposition.
It shows up temporarily in the world of the material appearances, changes there, and withdraws sometime again into this nothingness. This model can be transferred to the...
That's not a model. That's a bunch of words that kind of sound cool together.
Quantum and vacuum fluctuation, just as to the lifespan of a human being or a star. Also, you and I consist on particle level of an innumerable number of atoms.
We consist on particle level of an innumerable number of atoms. I suspect there's a translation thing going on here. And actually, well done to them for hiding it for this long. That sentence didn't actually compute. Obviously, you and I are composed of a lot of atoms, but it is not an innumerable number, if that term even made sense. And there's no relation. The fact that you and I have a lifespan and a star has a lifespan doesn't mean we're the same thing. None of that. No.
The smallest of light particles and information. So is our universe an atom or not?
Yeah. I mean, your case so far has been not exactly stellar.
Certainly, our universe is not an atom, but consists of atoms. Neither the universe nor the atom are indivisible objects on the particle level.
Correct so far. Let's see if he can hold it.
However, the basic structure of the universe and the atom are similar.
And we lost it, just like that. No, not even a little bit. It doesn't account for, there's only one similarity in that big thing in middle and small things go round. That's it.
Also share a common primordial ground. How could it be otherwise? Because the universe is built up of atoms. Whether ideas concerning the cosmos in the cosmos are true or not, we cannot confirm today with certainty, but nor can we exclude it.
Teach the controversy. We have an unfalsifiable idea, so we just don't know if it's true or false because we can't falsify it because it's freaking nonsense. Okay.
Have to wait for what researchers find out in the future. If we consider how far particle research has developed in the last 100 years, we will probably already have a completely new picture of the universe and atoms in 10 or 20 years.
I don't know about 10 or 20 years, but yeah, eventually we probably will. That's how science works. When we get a better model, we upgrade. When we learn better, we do better. It's good stuff. But as you can see, we are at the end of this video. All in all, I don't know. I don't know whether I'm impressed with how over the top that was, or really disappointed at how badly the science was misunderstood in that, and things were confused and conflated and equivocated. But I will give them this. It was very different from the other Is the Universe an Atom video. So even though they clearly plagiarized the thumbnail and the title, the content was unique. But it did give us a good opportunity to discuss a whole bunch of random science, and I am always in favor of that. Thank you guys so much for watching, thank you for subscribing, and a big thank you to our supporters on Patreon. As you know, this channel is relatively new, and we're still a long way from monetizing, and even the big established channels depend on community support to produce their best work, so we are very, very grateful to our supporters on Patreon. Thank you. And as always, remember, you don't have to gish gallop a bunch of half-understood woo-woo terms in order to try to make a point that is not supported in any way by real science, because you are better than quackery.